Hello, good afternoon. So, what is the subject that we are going to start with? Are you aware? Yes. So, I am Prem Surani, and we'll be discussing physical geography in this first classes, some initial classes. What is the assumption that I'm taking here is you have basic knowledge about this subject, right? Yes or no? No, sir, we don't have. इसलिए हम यहाँ पे हैं. Hey, you have the basic knowledge, right? Okay. So, in this classes of physical geography, we will divide this entire section into three parts. That is geomorphology. Second part would be climatology, and third would be oceanography. Now, if we consider the weightage of this subject, geography, how much do you think the questions are coming from this geography subject alone in last 2 years? Last year, how many questions were there? You were in some foundation course, okay. Around 20, yes, exactly. There were 20 questions. In last year, they were around 10 to 11 questions were there. It means if we combine this subject with the environment, this subject is something that can give you a lot of marks, especially they too are vital for clearing prelims, right? So without dealing much, let's go into this subject. We will see these three pillars. The first pillar that we are going to start with is geomorphology. Geomorphology. The initial this class maybe for some, let's say 1.5 hours, it may become slightly it is because the complex part we are going to handle, that is the formation of earth, origin of its, let's say, universe and all, they are something which is thoda sa theoretical part. You may be, let's say, feel a little difficult, but I promise that these are the areas which we are going to take. They are going to be most interesting part for you. Okay? I promise that. And the another promise is if you will handle these classes well and attend them well regularly, I can assure you that 90% of the questions you will be able to handle. Don't worry about that. Last year, 20 out of 20 questions directly from the classes. Okay, 20 out of 20. I'm not saying even one question, I'm saying word by word. Okay, they were covered. Last year also, I can say 8 questions were there directly from the classes. Again, I'm promising that if you will handle these classes well and attend them regularly, revise them properly, you will be able to finish all of the questions. Okay? In the geomorphology, the first section that we are going to start with, the first we will try to understand origin of Earth and its evolution as a planet. Its evolution as a planet. Why we need to see this evolution as a planet? Because as a planet means how it started supporting the life form, various form of lives, how they started evolving, yes. Then how the different kinds of, let's say, layers which are there inside, they emerged. How the atmosphere, which was earlier known for absence of oxygen, how this oxygen came to the planet, that is something that is crucial to understand, right? So we will understand here, that is our atmosphere, hydrosphere, that is how this hydrosphere, oceanic bodies, they came. Then the formation of life also, this becomes important for us, especially for prelims. Okay. Then we will go into the next, slightly again, a little difficult, but not that much. That is geological time scale. In this geological time scale, from prelims point of view, some detail is required, some. Okay? For example, if I say the Himalayas were originated in tertiary, if you do not have the idea where this tertiary is, then how you will arrange? For example, if I give you one question, arrange the following features in terms of their age. For example, if I give you the Deccan Lava Plateau, Himalayas, the plains, tell me which is oldest. Deccan Lava Plateau, Himalayas and plains, if I am giving you, which is oldest out of the three? Deccan Lava, yes. When it was formed? It was way back in Cretaceous, yes or no? Cretaceous. So this much of slight detail at least is required in order to understand this type of questions, right? Then for example, if I ask you, one question was asked, for example, the question is, India's most of the coal belongs to the Gondwana age. Yes or no? Yes. Which is the best coal? Anthracite. It was formed mostly in which age? What is the time period in which this anthracite formed? It is Carboniferous. Yes, very good. Now tell me, which was the last ice age? In that four were the periods. In that four, Gunj, Minde, Ris, Worm. What was the last one? For the prelims, you should know some this kind of tricks, Hana? Because they can play with this kind of tricks. One question we have also seen somewhere they have been asking from the areas where the planets are there. For example, sometimes they are asking, what are these meteoroids? What are these comets? Right? So some basic knowledge is required. After this geological time scale, we will go into theories part. Theories. In this theory, some of the very crucial and important theories that we will learn. The first we will learn CDT. What is CDT? Continental drift theory. This year there was a question from here. Yes or no? 2025 prelims. Very simple evidence-based questions. Right? Then we will learn the second, convectional current theory. Then we will enter into the another theories, but before going into them, we will first understand the interior structure of the earth, because that is required. So in the interior structure of the earth, we will learn some of the resources or the sources based on which we have drawn this interiors of the earth. In that sources, this is the most favorite area of the UPSC. They will ask you what sources are there, direct and indirect. Are you aware about them? So this direct and indirect sources, and in this one, the most crucial, that is seismic waves. This seismic wave itself is a favorite part of UPSC. In last 5 years, twice you will see the question came from the seismic waves, P and S waves, right? Then this is the important. Then with the help of these waves, we will understand what is the interior of the earth. Interior. In this interior, we will try to understand the various layers and this layered based arrangement. Okay, what are the discontinuities? What is the asthenosphere? What is lithosphere? Everything we will understand here in the interior of the earth. Then some of the areas, for example, the geomagnetism, how it is created, this will all come in this interior of the earth. After learning this interior of earth, now we will go into some more theories. For example, sea floor spread theory. We'll try to understand what this theory is. And then fourth, the last one, that is plate tectonic theory. And coupled with this, we will learn the mantle plume theory as well. Now, this plate tectonic theory is something which is very, very important from your UPSC point of view. You can go back and check one question in the mains is for sure is coming from this area. That is plate tectonic theory alone. Sometimes tsunami this year, 2025 mains. Sometimes the distribution of volcanic, let's say, activities. Sometimes the distribution of earthquake activities. Sometimes they will ask you the fold mountains and their distribution. In that way, this area is significant for your mains. At the same time, this is equally important for your understanding of that earthquakes, volcanic eruptions, trenches and all, which are important for prelims. Okay, so we will see this much. So this is going to be the first initial, let's say this 4 hours we will spend in this much of the area. Okay, we'll try to cover as much as it is possible. We'll try to finish this area, but I doubt because this is a lot of things to be done. Okay, so the first one we are starting with, just give the heading, that is the origin of the earth and evolution of earth as a planet. Origin of earth and evolution of earth as a planet. Fine. Now tell me, how earth as a planet evolved? Means what was the event from where every celestial objects came out? Big Bang event. So if we start with the Big Bang event, it happened somewhere around 13 to 15 billion years ago. Right? 13 to 15 billion years ago. And it is believed at that time the only thing which was existing, that was nothing but the singularity. What is singularity? It was, yes, it is tiny ball like ठीक है, it's not point, tiny ball like which was known for infinite density, temperature also, temperature, yes, density and temperature, and pressure was tremendous. Now what happened is, somewhat around 13 to 15 billion years ago, this, after reaching to the maximum density, infinite and temperature, what happened is this finally started exploding, and we can say this is nothing but, we will say, cosmic expansion. Now what happened is, in this time when this was expanding, in this expansion, just tell me one more thing, this singularity was existing in the space, or space came out from singularity itself? Singularity was existing where? In the space? Or space came out from the singularity? Space also came out from singularity. Yes, it is true. So nothing was there. We consider at that time only the singularity was existing, right? Now see here, why it was so, why the singularity was existing. For example, this is black hole. What do you understand by black hole? Yes, so can I say it is known for immense gravitational pull inside? Yes or no? And therefore, what happened is, whatever was existing at the time, we believe that it was nothing but the center of the black hole in which we had singularity. So now what will happen? Singularity broke, everything came out from this singularity, that is space, universe, everything, celestial object, earth, everything will come out. Now, what happened is, with this cosmic expansion, see here, for example, if we believe that the matter was coming out from here, let's say this is some objects which were coming out. I am considering right now them as galaxies. So what is, it is believed, now it has been established by this theory given by Mr. Edwin Hubble. He said that the galaxies are still moving further away from each other as well as from a common point. And he described this phenomena as a redshift. So what is redshift? When the two galaxies or the other galaxies are moving not only away from each other, but if we consider a common point, for example, this is the, let's say from this example, this is the common point. If I understand from this common point, G1 is here, the galaxy 1, G2 is here. The G1 is at the distance of D1 and G2 is at the distance of D2. Not only they are moving away from each other in this way, but also they are moving away from a common point. It means the universe is expanding in all the directions or in one particular direction. In all the directions, right? Now, what is this shift which has been given? This moment where galaxies are moving, this is called as are moving, which is characterized as redshift phenomena. Okay, redshift phenomena. Now, the galaxies are moving. Now, can you tell me which galaxy is moving faster in this diagram? G1 or G2? Which galaxy is moving faster? G2, of course, because it has traveled from a common distance, from a common point, more distance, yes or no? Yes. So please remember one thing which was suggested by Mr. Edwin Hubble. This theory was given by Mr. Edwin Hubble. Okay. The theory was given by Mr. Edwin Hubble in some 1920s. In this redshift, it has been proposed that the galaxy which is farthest, it is moving faster. The galaxy, for example, this has traveled 100 km of the distance. Hypothetical example, this has traveled 200 km of the distance. Can you tell me what is the speed of G2 in terms of speed of G1? Can I say exactly double? Because it is moving twice faster. Yes or no? Yes. So please remember, in this redshift, the galaxies which are moving faster, please write down this one. Galaxies are moving, the galaxies which are distant away, are moving faster, Okay, now tell me, this is the theory. Okay, everything was existing in the form of a tiny ball. This exploded. The expansion resulted into the formation of every planet, every galaxies. Galaxies are moving and expanding continuously, that we believe. Okay, according to this theory. Now, any of the theory is given based on some evidences, right? What we have the evidences, on which evidences we are basing this theory. What are the evidences? Kaise pata that this thing is going on, or this thing must have happened in the this time back, 13 to 15 billion years ago. How we come to know? Tell me. How you come to know? Ki yes, that is the exact phenomena.
In these days, we are calculating the gravitational wave that we receive, so distance can be known from there.
Okay, but at that time, abhi or aaj ke, last time, when this theory was given, what were the evidences? And now, what are the evidences in total? Tell me. क्या evidences हैं? What are the evidences? Yes, the universe is expanding. What are the evidences? We have right now, we are more advanced. We have one telescope in the solar, this system. What is that system, that telescope? It is itself, Hubble telescope is there. Yes or no? Yes, Hubble. Why the name is Hubble telescope? Because it was noticing this expansion. Yes, so we have now noted this down that yes, universe is expanding. This is one. But if we go by this natural explosion, any of the explosion results into some light elements creation. Yes or no? In the nuclear reaction also, neutrinos will come out. In the same way, something light element must come out from this type of explosion also. Yes or no? Yes. So initially, that entire universe which came out from this Big Bang theory or the Big Bang event, this was nothing but hydrogen and helium. What are hydrogen and helium? They are nothing but the lightest element. So which is found in abundance in our universe? It is hydrogen and helium. That is the one very crucial sort of evidence. Write down the evidences in favor of evidences in favor of cosmic expansion or Edwin Hubble's theory. Number one, abundance of hydrogen and helium. Abundance of hydrogen and helium. That is light elements. Abundance of hydrogen and helium, that is the lightest elements. Second, discovery of cosmic ripple. Discovery of cosmic ripple. R-I-P-P-L-E. Discovery of cosmic ripple. Who was the man sitting on the chair most of his life? What was the name? Stephen Hawking. He established this cosmic ripples and all. Okay? He was related to this discovery of cosmic ripple. Third one that you will write down, the experiment which was conducted, that is COBE experiment. Have you heard this name? COBE, C-O-B-E. That is Cosmic Background Explorer experiment. Write down COBE experiment and its findings. COBE experiment, C-O-B-E. In the last they are seats. Here also you can come. The COBE experiment, that is Cosmic Background Radiation Explorer or Cosmic Background Explorer. Then present day findings of Hubble telescope. Present day findings of Hubble telescope also suggest universe is expanding. Suggest universe is expanding. Okay. Now tell me. Yes, done. So this is the Edwin Hubble's theory and the evidences. Now tell me, okay, this is, we have learned what is redshift, what is how the universe came out. In this universe, let's say when universe was coming out from this entire process, the one planet which emerged out, that was the planet Earth. Right? The planet Earth. Now the thing is how the planets formed. What was the process? How the planets came out from this entire event? What must have happened? Yes, what was nebula? First tell me, what is the nebula? Yes, nebula was the first such body, that is celestial body, which formed out from this, yes, nebula. It is nothing but the large clouds of gases. Which gases primarily? Hydrogen and helium. Very good. Now what happened is, tell me, after explosion, the singularity will start cooling, means the matter will cool down, yes or no? Initially the temperature was very high, but now it will start cooling. Now see here, when it was cooling, this kind of, let's say this is the cloud. Now in this cloud, what happened is the matter, that is the gases, they were rotating around. This were the gases. Now in this, what happened is in the center, okay, in the center, we have seen this coalescence was going on. Coalescence means these gases were coming and they were making lumps. the lumps of liquid, and finally what will happen here? You will see the formation of a star. Now how the star will form, please see here. This is the gases. Now when they will cool, they will convert into which state? Liquid or solid? They will go to liquid state first. The liquid is slightly denser, and ultimately what will happen with further condensation or cooling, it will convert into solid. Now please understand carefully, in the center now a kind of this body or the object was formed, and around this object, this entire the cloud made up of hydrogen, helium, it was rotating. Still it was cooling. The matter which was cooling down, it was coming in the center. Can you tell me why it was coming in the center? Because it was denser, and this method, when denser matter came inside, or the denser matter which goes inside towards the center, this method is known as gravitational collapse. Okay, gravitational collapse. Now what happened is, in this gravitational collapse, the matter was sinking towards the center, and now what happened is, in the center a kind of denser, this planet-like structure was about to form. Okay? Please remember, if the central temperature, now tell me, if the matter is going towards the center, what will happen to the temperature inside the center? Will it increase or will it decrease? It will increase. Now what happened is, you were also in some batch last year, 2023. Last year. Which batch? Batch name. D7 mein the. Okay. So what will happen? The matter, when the gravitational collapse was going on, in that case, what happened is the temperature of the center was increasing. And if this temperature will cross some 10,000 million degrees centigrade, then what will happen? The nuclear fusion process will start. Yes or no? Yes. What is nuclear fusion? Where the two atoms or the let's say they will combine together. Will it cause the immense amount of release of energy? Yes or no? Yes. Now what happened is, here in some cases inside the nebula, this central temperature crossed the temperature of 10,000 degrees C plus, million degrees C plus. And therefore what happened is, the nuclear fusion process started. With this nuclear fusion, now tell me, what is a star and what is planet? Star means, yes, star means they have their own source of light. And what is planet? They do not have their source of light, rather they reflect the light from other planets, or other stars, right? Now how the star will form? This matter lumping together, gravitational collapse resulted into high temperature. High temperature started the process of nuclear fusion, and this nuclear fusion was responsible for sustaining their source of energy. And then what will happen? What is this now? It is a star or planet? It is now a star. And now what happened is, when this formed a star beyond, let's say, some temperature, this is now a star. Around this material was also cooling down, where the lumps were forming, and these lumps were collecting together, coalescing together, and they resulted into nothing but a kind of protoplanet-like structure. We will call them planetesimals first, then they will grow in size. See here, please understand this carefully. This is, let's say, the small drops of the liquid. Hai na? If I put my finger on this drop, what will happen? They will join together? Yes or no? And what will happen? They will grow a bigger drop. Out of the 7-8 drop, what will happen? Just do this experiment. Keep some 7-8 drops together. Just put a finger on them. What will happen? They will combine in a one bigger drop. The same kind of process was going on when this, let's say, the small body objects were rotating around this central part. They started coalescing them, or collision was started. Because of the collision, they ultimately joined together. They formed planetesimal. These planetesimals will further grow by this process of collision, and ultimately they will convert into what? A planet. Now, how the planet is going to be different? The planet will not have its source of energy. So what happened is, these bodies which were revolving around, they started evolving in the form of planet, not the star. The star in the center. The solar system, if you will see, in the center of the solar system, what is that? Sun. So sun is the example of what? A star. Whereas planet is the example of what? Nothing but in the nebula, these planetesimals were growing and they were converting into planet. This is something I will not going to dictate. Just see your handout. I will give you, your handout will be given shortly, I think. And you want to write something about that? Just write down how the, first write down how the planets were formed. Formation of planet. What happened?
So you mentioned during the lecture that when gases come together, they convert into liquid.
Liquid, huh?
I'm not able to relate. Why did you say that?
What will happen after the cooling? If the water vapor is cool, what will happen? Water vapor will convert into what? Steam is coming out, yes. So it will convert into water. So water is which form?
So water is being formed. There is hydrogen. There is helium.
Hmm.
Water is being formed.
I am not saying water is being formed. I am just giving you hypothetical example. See, the kind of gases were there, and ultimately these gases are joining together. What will happen? How the atmosphere will evolve? You will come to know. Rest of the matter is also there. In that matter, see here. In this matter, please understand the cooling is causing them to convert into more denser. Okay? In this more density, towards more density, they are converting into liquid-like stage. Earth was also similar. I'll talk about Earth's evolution. There you will understand how exactly this happened. Okay? Evolution of Earth, how Earth will evolve, we will see that in some processes. First, write down the formation of planets. Write down. Formation of the planets. Write down planets formed after the Big Bang event. Formed after the Big Bang event. After the Big Bang event, through the nebulas or in the nebulas. In the nebulas. Please write down one line about nebula. Nebula was the cloud made up of atmospheric gases, primarily hydrogen and helium. It is also considered the first structured matter. Nebula you are writing. It is also considered first structured matter after Big Bang event. After Big Bang event. And it is also referred as birthplace of stars and planets. Birthplace of stars and planets. Now write down formation of planet. You are writing formation of planet only, means come back again to formation of planet. Write down. The planet formation started with following process. Number 1, gravitational collapse. Number 1, gravitational collapse. Write down inside nebula, higher density matter pulled inside the center. Higher density matter pulled inside the center. And therefore, temperature and pressure of the center increased. Temperature and pressure of the center increased. Second step, protostar formation. Protostar formation. Protostar formation. It is the early stage of a star. It is the early stage of a star where collapsing gases formed a disc-like shape. Disc-like shape with high temperature in center. With high temperature in the center or in center. Next, when the temperature inside center reached about 10 million degrees centigrade. 10 million degrees centigrade. Nuclear fusion started. Where hydrogen started converting into helium. with this process, stars were formed. With this process, stars were formed. With self-sufficient nuclear reactions. With self-sustaining and self-sufficient nuclear reactions. Leftover material, next point, leftover material that was surrounding the center, started cooling and lumping together. LUMP, started cooling and lumping together. Where cosmic dust and other particles collided. Cosmic particles that collided and they grow bigger eventually. Over million of years, these small rocky bodies, that is planetesimals, merged through collision, and with gravity, to form protoplanets, and eventually they resulted into formation of full-grown planet. Okay, full-grown planet. Done? See here, this is what we have discussed. We have written what was exactly happening here. The evolution we will further understand when we will talk about Earth specifically, right? Now come to the next one. See here. Now if we talk about our solar system, so in the center we have our sun, right? So what are the planets here? What are the planets initially? This is the belt. What is the name of this belt? Asteroid belt. Okay. Now see here. These are known as terrestrial planets, right? Terrestrial planets. And the other one, they are known as Jovian, or the outer or the gaseous planet. Gaseous planets or the Jovian planets, right? Now, if you see this Jovian planets, they are bigger and they still are holding their primordial atmosphere. What this primordial atmosphere must be composed of? Mostly they must have the gases more than, let's say, what they are in the surrounding of these planets. Yes. So now can you tell me why still they have this primordial gases with them? Why? Because of? Yes, very good. Because of their bigger size, they are having the bigger gravitational pull. Yes or no? So they are, this is Jupiter, bigger one, right? So this is bigger and therefore they have immense gravitational pull inside. Yes. Now because of this gravitational pull, they are still holding their primordial atmosphere. Now, when it comes to the inner planets, that is the terrestrial planet. Now, see here, for example, they also had this helium and hydrogen in abundance. But now what happened is, because of the solar winds from here, what happened is this outer atmosphere was stripped off of these planets. Why? Because of two reasons. Number one, the solar winds were intense here because they were close to the solar wind, and second, because they do not have the much power, the gravitational pull similar to this Jovian planets. So now they do not have this kind of gaseous atmospheric conditions around which are otherwise available here. So please write down this one. This was the solar winds. So here I'm writing they were smaller. The gravity was lesser. And they could not hold, could not protect or hold their primordial atmosphere which was stripped off due to solar winds, which were most powerful in this area because of they were very closely located. Now asteroid, Hanji.
So we call them gaseous because they have more gases because Earth
Yes,
also has gases.
yes, they have more gases around. They are
Have crust.
yes. Because they have the gases around them and they are still holding. And most of these Jovian planets, you will see a kind of discs will be there. Okay? However, some of the planets will not show you this disk in visible form, but still they have this rotating gas masses, right? So that is true. They both are, but they are more rocky. They have more gases. Why? Because their gases are stripped off, but still they are holding the gases. So therefore, they are known as gaseous planets also. It does not mean they have the entire gases. No, they have the rocky material also. They have more rocks, okay, more land masses. Therefore, terrestrial planets, they have the more gaseous component around and they are gaseous planet. Now, please remember, what is the asteroid? What are the asteroids? Asteroid? Yes, why? Why they could not coalesce? What happened to them? These are the small, this rocky objects. They are revolving in between this belt, in this between the Jovian and the terrestrial. Now, why they could not collide? What was the reason? No. They were close enough. Why they could not collide? Yes, very good. It was because of strong gravitational pull of this Jupiter. Please remember, asteroids, they are small rocky bodies, small objects, the celestial objects. Please write down what are asteroids. They are small rocky objects. They could not collide, or they did not coalesce or collide. They did not collide in the presence of a strong gravitational pull of Jupiter. A strong gravitational pull of the Jupiter. Okay, they are found in between Mars and Jupiter. They are found in between. Mass of the mass of the any, let's say if the size is small but they have more mass, then they will have more gravitational pull. But still the whole mass, when you will compare, they will come here. Okay, so it is the asteroid belt which is found, which is located in between Mars and Jupiter. Okay. Now, can you tell me what is meteoroid? There are three things that you should know. What is meteoroid, what is meteor, and what is meteorite? The three things. What is meteoroid first? What is meteoroids? The second is what is meteor, and third is what is meteorite. Can we say these are nothing but the small bodies of the objects which are created nothing but from the asteroid? Okay? So they are nothing but rotating here only. They are nothing but, what are the meteoroids? They are celestial objects created from the asteroid. When the asteroids are colliding, the meteoroids can be formed. Okay? Now, what is meteor? When it enters into Earth's atmosphere, then what will happen? Why? Because of the friction and the heat? Yes, very good. Now tell me, what is meteorite? When it lands on the planet, right? So please remember this small things, they are quite important for your prelims. See here. So when it comes to our atmosphere, the atmosphere is denser, especially up to 80 kilometer. Yes. And this is nothing but your mesosphere will be here. Now what happens is, this is meteoroid. Here it is the celestial object. This is meteoroid. Now when it tries to enter in our atmosphere, what happens is it will start it burning because of the heat and friction. In which layer it will happen? Mostly it is in the mesosphere. And then what happens is, because they are also made up of very strong core, made up of this iron and nickel. So what can happen? The core can hit the surface sometime. It can survive the entire this heat and friction. So then we will call this nothing but meteorite. Okay, this is here with the long tail of this kind of shooting star like. This is known as meteor. Okay, so meteorite first. Write down one line only. Meteorite. These are the celestial objects. Meteoroid, they are the celestial objects. Celestial objects created by collision of asteroids. They are made up of nickel and iron mostly. They are made up of nickel and iron mostly. Okay, next, meteor. Meteor. These are the meteorites. Meteoroids. These are the meteoroids entering into Earth's atmosphere. These are the meteoroids. Meteoroids roids entering into Earth's atmosphere. They burn inside mesosphere due to intense heat and friction. They burn inside mesosphere due to intense heat and friction. However, their dense core can survive. And can reach on the surface of the earth. Then it is known as meteorite. It is because of the gravity here. Earth's gravity is very high. So this atmosphere is known. What is the definition of atmosphere? The gaseous envelope which is surrounding the earth. Why it is gaseous envelope is surrounding? Because of gravity. So the immense gravity causes the gaseous cover is more or less denser near the lower layers. So up to this 80 kilometer, this gravitational pull is good enough. And therefore most of the atmosphere, the denser atmosphere, lies up to this 80. Beyond that, the atmosphere will lose its density. It will become rare, less denser. Okay? That is because of the gravitational pull. So due to this gravitational pull, the gases are being pulled downward. Okay. Next is what you were writing? Meteoroid is over, which is known as meteoroid. Next is the last one. That is, now we are coming to the evolution of Earth as a planet. Okay. Evolution of the earth. I will give you one document. There some planet related information would be there. Please go through that for your prelims. I can't discuss that because it becomes otherwise science. So we'll give you one handout, some planet and there some characteristics important for your prelims. Now come to the planet, that is Earth, and how it got evolved. So Earth, somewhat around 4.5 billion years ago, it started evolving as a planet like Earth. Okay. Initially, it was barren. Yes or no? Initially, it was barren. It means there was no life form, and also there was no oxygen. So now what is the thing that we are going to learn here? We will try to understand the evolution of Earth in three phases. Number one, that is how its atmosphere, which is now rich in terms of oxygen. For example, now we have nitrogen somewhat around 78%, oxygen somewhat around 21%. Now, how this came into being means how we evolved from 0% oxygen to this much. Okay, so we will understand. And then second dimension, we will understand that the first one is atmosphere. Second one is lithosphere. What do you understand by lithosphere? Or we can say here, we can say the interior of the earth we will try to understand here, including the more inside layers. And then third, we will try to understand the beginning of the life, how these all things happen. Okay, so there are three things that we will try to understand. The first one, we will start with the lithosphere. Okay, because we have just learned in the lithosphere, see here, this was the earth. Initially, it was coming out from the nebula. Okay, the planet's formation we have learned. In this planet, when earth was evolving, the earth was initially in which state? It was initially in the gaseous stage, and now it is cooling down. Because of this cooling down, what will happen? The lumps will be formed here, and what will happen? These lumps will collapse down inside, yes or no? The inside temperature will nothing but increase. And now tell me, what about the density? The inner core, that is the inner material, will become more denser, yes or no? Yes. So now see what is happening. The gases which were cooling around, the entire this structure of the protoplanet and planet was cooling down. In the process of this cooling, what happened is the lumps were forming, and the denser lumps, they were now collapsing down towards the center. Please remember this thing from the Big Bang event itself. Because of difference in size, the different was the gravity with the celestial objects. Please remember, the gravity differentiation started right from the Big Bang event itself. Okay? Some of the planets, they were bigger. Some of the celestial bodies, those which were bigger, they were having more gravitational pull, and therefore they were just having this more area around. They were collapsing more and more material towards the center. In this center, if the collapsing was going on, what is this method is known as gravitational collapse. Because of the gravitational collapse, what will happen? Tell me now, the inner temperature I am interested in. So what will happen to the inner temperature? The inner temperature, the core temperature will increase. Now inner temperature, if it is increasing and its pressure was also increasing, tell me what will happen to the density in the inner part? The density will also increase. Yes. Now see here, if this more denser material is collapsing down, what will happen to the lighter material? It will come out on the surface because the center is getting occupied by the denser material. Yes. So now what happened is, can I say it was possible, the differentiation of the densities was possible when the earth was in liquid state? Yes or no? Tell me yes or no. If the earth was liquid, then the movement was possible. The denser one is coming down, the less denser will go up. Now, if I consider the earth is solid, is this possible? The denser rocks are going down in the center. Ki jagah do, we are denser, we will go down. No, na? So can I say it was because of the temperature inside the earth was very high. The earth was in molten state, and therefore it was possible that denser material was collapsing down, the less denser material was coming out on the surface. Yes or no? Yes. So please remember, the gravitational collapse resulted into very high temperature. This very high temperature was further responsible for this molten state. And this molten state was something which was desired, where the denser material will further go down towards the center, the less denser material will go up. And can I say with this, the gravitational collapse, the inner rise of temperature, they all were responsible for what? The difference in the density inside highest density, intermediate density, and lowest density here. Can I say now we have inside the earth, how many layers are there? 3. Crust, mantle, and core. Can I say the density based differentiation of the earth can be understood with this gravitational collapse as well as the rise in temperature? Yes or no? Yes. So please remember how this process started. The gravitational collapse and rise in temperature were responsible for difference in the density. So please write down with me. Write down with me. Write down. Please write down. Gravitational collapse resulted into rise in temperature. Rise in temperature was responsible for density differentiation of Earth's interior. So what happening in this time? In that time, what was happening? The inner core, here the densest material came down. The intermediate density material and the lightest material was floating on the surface. It is temperature. It is not related to this density. Now what is happening? The material is going inside. The compression is increasing. So what will happen to the temperature? Then temperature is increasing. Who is responsible for rising this temperature? The denser material which is falling down. Then this is the density which is causing rise in temperature. And this rise in temperature will keep this inside in the molten state, which will further support some of the matter will collapse down and some will go up floating. That is how the density differentiation was resulted into, and this three type of layers were formed. So please understand, this method was responsible for layered structure of the earth. So the first thing that we have understood, how the layered structure of the earth was formed. Again, I'm repeating, please remember for the prelims this sequence, that is gravitational collapse, rise in temperature, the molten state, and this rise in temperature was responsible for density based differentiation. Okay, for the prelims. Now come to the second. This is how the lithosphere, that is the uppermost part, that includes this one. Please understand, lithosphere is the uppermost part that includes the entire this crust and some portion of the mantle. This is the lithosphere. We will come to know when the structure of the earth we will discuss. Okay. So the first is how the lithosphere or the internal layered structure was formed, that we have understood. Now the second thing here is we will try to understand how the atmosphere got evolved. Okay, done up to here, everyone? Fine. I already said this is something which is slightly theoretical. Then the geography will become very easy and interesting. For how many geography is difficult? Let me know. For how many the geography as a subject is very difficult? Honestly, raise the hand. Very difficult. And for whom it is very easy wale. Okay. And for moderate, most of you moderate. Okay. For geomorphology, difficult. Geomorphology as difficult. Okay. Okay. And what about climatology? Difficult for? Moderate to difficult. Okay. Okay. Now come back. The second one, the atmosphere. Okay? See here. Atmosphere, how it got evolved. Atmosphere, if we see here. I am considering now, see here. I am considering now that this was the structure of the earth. At that time, it was very rough here and there, right? In that time, the earth was cooling. Now tell me, when the earth was cooling, what will happen? Inside the earth, we still have very high temperature. Just now we have learned the gravitational collapse, the very hot temperatures inside. Now, when earth wants to cool, what will happen? The inner heat which is trapped, it will try to escape out. When this heat will try to escape out, in the form of what it can escape? In the form of volcanic eruption, yes or no? Yes. So what happened is, it is the earth's inner heat which was trying to escape out, and this inner heat escaped in the form of volcanic eruptions. A lot of volcanic eruptions were going on. In this volcanic eruption, along with some gases, the more important thing for us is to understand water vapor also came out. Okay? Now what will happen? The outside, when this entire heat is coming out, the water vapor is coming out. Now tell me, inside it was colder for this entire gases or outside? Outside. Now what happened is the water vapor was now going through the process of here condensation because of the cooling. Now what happened is through the condensation, what happened is the rainfall started. Now please understand, in that initial time period when I am talking about, this is somewhat around 300 million years ago, I'm talking about 3.8 billion years. In that time period, our atmosphere was known for very high concentration of CO2. The CO2 was very high in our atmosphere, right? Now, tell me, with rainfall, if the rainfall is going on, can I say the H2O with this carbon dioxide will come in the form of H2CO3 in the water? What is H2CO3? That is the carbonic acid. Now, please see here. When this cooling and condensation process was going on, with the rainfall, atmospheric CO2 was removed with the rainfall. Now what happens is CO2 concentration will decrease or increase in the atmosphere. It will decrease. Yes. Now there were some depressions, this kind of depression. In these depressions, the rainfall water started depositing, and this is nothing but your sea and oceans are going to form now. Okay. Now see here. What is the process? Heat is trying to escape out, volcanic eruption, water vapor, condensation, rainfall. With the rainfall, the water is coming up with the carbon. Carbon is getting removed from the atmosphere. The water, which is highly acidic with this weak carbonic acid, it is started depositing in the some depressions. These depressions were natural depressions, and this is how the sea and ocean is going to form. Okay, so now tell me, the Earth as a planet evolved in somewhat 4.5 billion years ago. Tell me, only after then the oceans started forming, or before the oceans were there? Earth came out from the ocean. Oceans came after the evolution of the planet Earth. Yes or no? Yes. Now see here. Further, the volcanic eruptions were going on. And now tell me, with this second phase, please consider this is the second phase. Now tell me, atmosphere is much cooler or the less cooler than earlier? It is earlier, it was cooler. Now it is much cooler or less cooler? Why it is much cooler? Because CO2 has been removed and the condensation was faster, and this was resulting into more removal of CO2 from the atmosphere. So please understand what the things are going on. With this evolution of hydrosphere, see here, with this cooling process, the hydrosphere is coming into being. Seas and oceans are forming. At the same time, our atmosphere is now going through one more process. What is this process? The CO2 is getting washed away by this rainfall, continuous rainfall. And in that way, atmosphere, now see here, if I come back to atmosphere, the three things we were learning now, see here now. The atmosphere evolution, that is the second one. Evolution of atmosphere. This happened in three processes. Number one, see here. Number one, already we have learned what was that? Solar stripping. The stripping caused by solar winds. So number one, it was the solar winds where primordial atmosphere that was rich in hydrogen and helium got stripped off. So this is how our atmosphere was stripped off, number one. Number two, this process which I was repeating, this process is known as degassing, where the gases were releasing from the inside. Second process is degassing. So what happened in the degassing process? The gases were released, came out from volcanic eruption. From volcanic eruption. Then what happened is the gases, if I'm talking about, the more important gas was water vapor. The water vapor got condensed and the rainfall started. Rainfall started, with which CO2 from the atmosphere also washed away. Okay, so this is how the second thing is happening here. That is, with the degasification, CO2 concentration was decreasing from the atmosphere, and this rainfall water or the rainwater collected in depression, it was resulted into formation of seas and oceans. Okay, seas and oceans. So the second important process is degassing. How it is related to atmosphere? It was removing the CO2 concentration away from the atmosphere. Okay, number 2. Number 3 is the atmosphere got modified because of evolution of life. Okay, now see what will happen. See here, the third process, just I'm writing, I'll explain. That is evolution of life form and modification of atmosphere So how they will modify this atmosphere, we will try to understand. Now see here, please, for the prelims, remember these points which I am discussing. They can be asked in the prelims. Okay, now see here, let's say this was the natural depression, and now after the rainfall, this depression was filled with the water. That is nothing but our seas and the ocean. Now sea and the ocean, or the molten form, that is the liquid form, is considered as the magical liquid, the water. Why we go to other, let's say, the other stars and other planets in order to search what? Water. In the water's presence, what can happen? If you are, let's say, engineers, most of the time what happens is engineers keep their food material and water outside for a good number of days. Then if you come back from the leaves, you will see some life form is evolving inside that liquid. Have you seen that? Kaise? How it is possible? No, just clean water aap chhod ke dao. And after some time, let's say when you will come back, you will see some life form. Have you seen that? Engineers ko to relate kar pa rahe honge. Yes, I don't know about others. So life form will start. Why? How the life form started on the earth? कैसे evolve हुए? How this evolution happened? How the life came into being? It came from the oceans, or it will emerge on the land? From the ocean. This is the magical liquid. है ना? Now see here, it is now believed that there was some chemical reactions. So initially it was believed due to this chemical reactions, what happened is a kind of organisms started evolving. So please remember, it is believed that the chemical chains and the chemical reactions were responsible for the origin of the life. And this type of chemical related organisms, they will evolve from unicellular, most simple, to multicellular, and this process was started. Okay? So the evolution of the life form, it is considered, see here, evolution of the life form, it is considered initially chemical, and then later it converted into biological. Initially simple, then later it became multicellular and complex. Okay? So now tell me how this evolution of life form will impact this atmosphere. Yes, so what will happen? That, for example, the plants will evolve over a period of time. They will pull the CO2 from atmosphere. At the same time, they will release the oxygen into the atmosphere. So how they modified? They used CO2 in, for example, photosynthesis, and they released oxygen in the atmosphere. Remember one thing, this evolution of life started from liquid, started from water. That is, can I say now seas and oceans? That is from seas and oceans. Okay. The last question, that is how this life form originated on the earth, that we have discussed just here. So please write down the evolution of the life form. It is considered the origin was chemical. Origin was initially, it is considered initially the origin was chemical in nature. That is, with chemical reactions, life form evolved. with chemical reactions, life form evolve. And later, biological organisms emerged. Later, biological organisms emerged. Okay. Now tell me, if I ask you one question, see here. If I ask you this question, that is the evolution of the Earth's lithosphere can be contributed to following. Number one, the gravitational collapse of the matter. Yes or no? Yes. Tell me the second, the big split event. Are you aware what this event was? Formation of moon. So what happened at that time? The moon was considered, that was how it was formed. It is nothing but one object was hitting the yes. So what happened is, it is considered, see here, the moon is nothing but it is the part of Earth. Okay, it is from this event. See here, when some big object was striking the Earth, and this portion, it is coming out from the Earth in the form of moon. Tell me, when the lithosphere was evolving, was that modified because of this big split event? Yes or no? What will happen if the celestial object is hitting the Earth? What can happen? Can I say it will change the temperature compression effects? Yes or no? Yes. Can I say therefore it can also be held responsible for some modification in our lithosphere as well? Yes or no? Yes. Please, one more point, just write down there in lithosphere's evolution. Last point. Big split event. Here. You will write here. Where at this point? Just write down this one last point. That is big split event, formation of moon with collision of celestial object, which was nothing but the formation of moon with collision of celestial object and Earth. This will come out as moon. And this is also considered one of the factor. Also impacted evolution of lithosphere particularly. Mainly by increasing the temperature. Okay. So second part of this chapter, that is, we are done with. Number one, we have learned the origin of the universe, planet and stars. And the second, we have learned how Earth as a planet evolved. Okay. Now we are a split event. Done. Now the third thing that we are coming into, this is on the surface we will see, because otherwise this entire lecture will be blown away by this geological time scale. So we are going to see geological time scale now. Okay. Geological time scale. Now if we see geological history of the Earth, for example, it is, if I take from Big Bang event, that is Big Bang event, and this started from 13 to 15 billion years ago. If we come to here today, that is, let's say, evolution of the Earth as a planet, that is 4.5 billion years of history. And if I come from here till today, that is Meghalayan age, that is nothing but under Holocene. Meghalayan age. that is 4200 years before present. Okay, so this entire is the history from the Big Bang event. This is the evolution of the earth, and this is the 4200, that is the Meghalayan age. This history, especially this history after the evolution of earth, this entire history can be divided into certain time stampings. For example, in the clock we have the hand, let's say hour minute, the minute, then second, they are there. Okay? In the modern history, there are certain phases. Arrival of Gandhiji, hai na? Then before Gandhiji, after 1857, these are the phases which are nothing but remarking some major events. In the same way, some of the major events are marked in the geological history of the earth, and this is nothing but with the help of geological time scale. For example, if I say Aravallis, they originated way back in Precambrian. So what is this? Time stamping. The important event was the origin of Aravalli. For example, if I say the origin of the Himalayas, so when they originated, that is, for example, in Tertiary. So this is the big event. The life form, if it was evolving and it was going out, or it was wiped out, these were also marked by this kind of event. For example, Jurassic, known for what? Dinosaurs. They wiped out completely in Cretaceous. Yes or no? So Cretaceous is known for what? Wiping out of dinosaurs. The Jurassic, known for dinosaurs. Now, if I show you quickly just on this map, see here now. Climatology, this one. See here. Yes. See here. If we divide this entire history, see here, from the bottom we are starting. This is divided into some time stampings. The one is eon, the largest unit. The second largest, era, then period, and then epoch. This further can be divided into ages. That is Meghalayan age, the most recent. Okay. See here, in the bottom, this time period, that is including this 3 eon. Hadean in the bottom. Hadean in the bottom. Then Archean, and then Proterozoic. These three combinedly are known as Super Eon, and they combinedly are also known as Precambrian. Why Precambrian? Because here you will see the Cambrian time. See here. Eon, era, period, and epoch. Please see here. Let me give you this classification with this table. See here. So what is the major and the biggest unit? Eon or era? Eon. Then second, era. Then yes, and then finally we have age. Okay, so I am saying here, see here, eon can be divided into two. See here, number one, this is a Phanerozoic time. A Phanerozoic means when the life form was invisible. A Phanerozoic, and here onwards the life form will come into picture, or the life will emerge and this will be visible. Okay, so this is Phanerozoic. This is a Phanerozoic. A Phanerozoic will have 3 eons. What are these 3 eons? Protoro, then Archean, then we have Hadean. Okay, please try to understand this classification. Then we have eras here. In this Phanero, we have era. Eras are divided into 3. One is the Paleozoic. Then second is Mesozoic, and third is Cenozoic. Okay, now see here, this Paleozoic will be divided further into 6. That is Cambrian in the bottom. Yes, Cambrian. Then it is Ordovician, Silurian, Devonian, Carboniferous, and Permian. Okay, again I'm repeating. Cambrian, this is Ordovician. It is given in your handout. Okay, just match that. Cambrian, Ordovician, Silurian, Devonian, Carboniferous, and Permian. Okay, so this is because of the Cambrian. Whatever the time period is there before Cambrian, this entire time is known as Precambrian. Remember, this is 89% of Earth's history. Exactly 88% of Earth's history, geological history, lies in this area. Whatever we are learning, it is only 11% of the time. Very recent time, it is starting from Paleozoic, Meso, and Ceno. Now see here, this is further divided into 3. What these 3 time periods are? This is your Triassic, then Jurassic, then Cretaceous. Then we have here, what are the divisions? Tertiary and Quaternary. Tertiary is further divided into 5. We will see that what are the 5. That is from Paleocene to Paleocene to Paleocene. Yes, and then here Quaternary will be divided into, tell me, Pleistocene and Holocene. This is Pleistocene and Holocene. Holocene is the most recent time period. In that also we have 3 divisions. The most recent is Meghalayan age. That is 4200 years before. Got this? Please understand this quickly. See here, again I'm repeating. Hadean in the bottom. We have then Archean. This Archean time period is something where your cyanobacteria will evolve and the oxygenation process will start. Proterozoic, it is here, and abundance of oxygen will come inside the oceans. Cambrian, Ordovician, Silurian, Devonian, Carboniferous, Permian. These are the phases of inside this. See, Meso is divided into 3, then Ceno, Quaternary and Tertiary. They are further divided into Paleocene plus this one, Paleocene to Paleocene, Paleocene to Paleocene. Then Quaternary will be divided into Pleistocene and Holocene. Holocene will further divide into 3. Now, with this practice, there is no other way. Some logics, see here. For example, this is, you can remember with this cost cap. What is cost cap? Here, if you will arrange C, O, S, D, C, A, and P. In that way, you can make some mnemonic. Here, there is no need to remember. This is CJI of India. Just bring this one CJT. Just T, if I am putting here, CJI. Okay? So, this is Cretaceous. This is Jurassic. This is Triassic. Okay? Then here, it is simple, Tertiary and Quaternary. Okay? We will try to remember all these. Okay? Done up to here. Now one by one, please understand what is the importance of this time period. See here, आपके इसमें दिया है handout में, just I have mentioned some of the areas. Precambrian I have mentioned, na? Precambrian I have mentioned, okay. And then NCERT's diagram it is, okay. Mostly the questions will come from this NCERT diagram. I am expecting, okay. If they will ask about this, see here now. See here. We'll talk about this Hadean. Hadean is hail-like. Hail-like means there was nothing, means there was no oxygen, no life form, nothing was there. Hell-like was the earth. Second is Archean. Archean is known for certain things. What are these certain things? One is the oldest rocks on the earth are found dated back to Archean. Okay, oldest rock. And these rocks are rich in metal. If you want to write some detail, chota point, just write down. Archean, about Archean. Archean is important for the old rocks found on the earth, rich in metals, especially which metals? Iron and gold. Iron and gold, yes. Kolar gold field, that is Archean rock area. Okay, metamorphic rocks. Archean rocks are famous for, they are oldest and they are known for the metallic minerals, especially iron and gold. Okay. Number 2, see here, that is also known for the oxygen, this one, formation of blue-green algae. Okay? See here, in your NCERT it is mentioned here, Archean, blue-green algae. Okay? So you will remember here only. In some of the debated it is also believed that they started here itself, but it is not believed. Largely it is believed blue-green algae originated in the Archean period. Okay? So please remember, Archean is also known for blue-green algae. And now what will happen? Blue-green algae are known for photosynthesis. So what will happen? Photosynthesis will start in this time period. Oxygen was added. Tell me where they will start. Cyanobacteria will evolve in oceans or on land? In the oceans. Now see here, in the oceans what happened is not only the food production, that is with the photosynthesis, but also the oxygen started. And therefore what will happen? Now you will see the life will thrive inside these oceans. Okay. So now see here in this Proterozoic, what will happen? You will see the abundance of life form, but still in the water, confined to the water. Okay, please remember. Now this Precambrian period is also known for some other things. For example, addition of oxygen we have learned. The second is the famous example, Aravallis originated during this period. It is written in your handout. Aravallis originated during this period only. What about the oceans and seas? They were also formed in this Precambrian time, yes or no? Yes. So, yes. So oceans and seas were also formed. I think time also I have given 3800. Is it mentioned? Is it mentioned? 3800 oceans. Yes. And then finally, oxygenation we have seen. Yes, ठीक है. Origin of the life. ठीक है. Earth's crust was also forming. Second, now come to here. See here. This is Cambrian here. Cambrian is known as the time of the marine invertebrates. What is vertebrate and invertebrate? Invertebrate are less important. They do not have this spinal cord. And vertebrate are the more evolved organism. So what is the time period? Cambrian time period is the age of the marine invertebrates. Please remember, it means the marine invertebrates were more in numbers. Inside still the life is, inside still the water. The life form is also not available right now also on the land. Land is not supporting this life form. Now see what will happen. The next one, Ordovician. Ordovician is the time period when your fishes will come. The first fish, it will be evolved here. It is there. First fish will evolve here. Now if we come to Silurian, the Silurian is the time when for the first time leafless plant emerged on the land. Leafless plant. It means it was very, very simple plant. And how we come to know that these plants were there way back this time? It is we have found fossils, and these fossils were recovered from Australia. Now see here, Silurian. Silurian means now what is going to happen? The land is going to support the life form. Why? Because leafless plants are now emerging on the land. And now see here, this period, Devonian. Please see here, Devonian. See here now. So if we go by this, see here, the life is inside ocean still. Now Ordovician, this is the first fish will come here. Then Silurian, first leafless plant, where? On the land. See here, this is the land. Now the life started in the ocean. Please see here, the sequence. The life started here. The life wanted to come out, but there was no support outside. No food, nothing was there. And for the first time, the leafless plant was here. Now what can happen? The life form can come out from this water in order to have some food and all. Yes or no? And this time onwards, after Silurian, what will happen? The land will also support this life. Support means this life will be supported by this land-based mechanism, but still this is not going to support them fully. So first, who will come? Those which are going to live here fully, or those which are primarily live inside the water, they come and then they will go back. This is amphibians will come first. So out of fish, see here the next time period after Silurian, Devonian. Devonian is known for the origin of amphibians. लिखा हुआ है? Yes. Now see here Carboniferous. Now Carboniferous was the time period in which we had trees of the height of 30 to 40 meter at that time. Okay, Carboniferous was good amount of tree and vegetation as well as the life was present. Now what happens is when the life is trapped, let's say the organic matter when it is trapped inside the circumstances where the temperature is very high and the pressure is very high under water condition. So what can happen? Please remember this with logic. See here. For example, yes. For example, this is some tree which was trapped here inside the earth. Why? Because earth was going through a lot of volcanic eruption, a lot of plate tectonic activity was going on. In that case, what happened is, let's say this is the plant which was trapped here over a period of time with temperature and pressure. And if it is submerged under water, so this water, if I consider this was fresh water body. What do you understand by fresh water body? Where the salinity is how much? Fresh water body means the salinity is in between 0 to 5 ppt, parts per 1000. Under fresh water, please remember this type of living sediments will result into formation of coal. Whereas if they are under this marine kind of water, so under marine condition, what do you understand by marine? The water is saline, let's say 35 plus ppt. Under such circumstances, what can happen? They will result into rather formation of what? Petroleum. Please remember this. Okay. So under freshwater condition, if they are submerged, then coal formation. Under the marine condition, if they are submerged, then what will happen? Petrol formation will happen. Now, if we go by this logic, the Carboniferous, the name itself is suggesting that this is known for what? Carbons. Carbon means forests were there. ठीक है. So Carboniferous time period is known for formation of which coal? Formation of anthracite coal, the best in category. Anthracite coal across the world. Across the world. Okay. Now please remember how many categories are there of the coal? 4. Anthracite, bituminous, then lignite, and finally last is peat. है ना? So see here, this is anthracite. Then we have bituminous. India's coal mostly of which category? Yes, India's more than 98% of the coal belongs to bituminous category. Third is lignite and fourth is peat. Now if I ask you a very simple question, tell me who will give you more calorific value? Which coal? Yes, highest calorific value, and the calorific value will be lowest. Now if I ask you where the smoke will be most, smoke will be least here and smoke will be highest here. Yes or no? Yes, smoke will be higher. Why the smoke creation is more here? What could be the reason of the smoke? Because of water content is still inside. So peat is something where the water component will be still inside, and the anthracite is the one which is more or less dry. The water amount is very less inside. Therefore, if you burn anthracite, less smoke, highest amount of calorific heat. And if you will burn the peat, it will give you more smoke, less amount of heat. Okay. Now, please write down here India's most of the coal. Yeah. The value, the heat amount, the heat amount produced by 1 kg, if you will compare. Okay. Now, please remember here, you can write down here, India has most of its coal of bituminous category, which is much recent in origin. India's most of the coal is of bituminous category. India's much of coal is of bituminous category, which is younger than, which is much younger than, which is much younger than Carboniferous coal. Carboniferous coal. One question was asked by UPSC. Tell me, in the prelims they have asked, India is having one of the largest resources of the coal, and still India imports coal. Why? Why we start? Still we are importing this coal. Why? What you will do with this quality coal? Bituminous coal is not sufficient for us. Where you need anthracite coal. Mostly we are importing anthracite coal. Why? In the steel production, why? Why not bituminous? We are importing which coal? Anthracite coal, mostly from China and other countries. Why? Then why impurities are something which is not desired? In which process especially? Why? In the steel making, if the coal has sulfur, that will cause bubble formation. And therefore, what is required? We do not need sulfur. Sulfur will be highest in the peat, the lowest in the anthracite. So in order to make a stainless steel, you need this anthracite coal. Okay, so write then this question. Why India imports anthracite coal? Please write down. Why India imports anthracite coal? Sulfur is lowest. Sulfur is lowest here. Sulfur is highest here. Sulfur content lowest, anthracite. The sulfur content will increase as you are going down. More amount of sulfur means more smoke. Okay. It is the best quality. Conversion has happened. Okay. So in that conversion only, how the category of coal is determined? By the amount of heat and smoke. This sulfur is something which will create also more smoke. The sulfur will give more smoke content as well. If the sulfur is produced by your coal more and more, what will happen? You will consider that inferior quality. Okay. So write down why India imports anthracite. Number one, because of two reasons. Number one, anthracite coal is used in stainless steel formation. where higher amount of sulfur in the coal, can result in bubble formation. Where higher amount of sulfur can result in bubble formation, and therefore with less content of sulfur, anthracite is desirable. Anthracite is desirable. Anthracite is desirable. Second purpose, India still generates most of its energy through power plants. Which power plants? Thermal power plants. India still generates much of its energy with thermal power plants. And to increase the efficiency of these thermal power plants, anthracite coal is mixed with bituminous. Anthracite coal is mixed with bituminous. Anthracite coal is used in bituminous. If you know about the India's distribution of the coal, just let me give you here just some idea. So, for example, this is India, where India's most of the coal formation lies. Yes, tell me. Yes. So, what are the areas? See here, most of our coal, which is the coal bituminous, it lies here. What are the rivers here, if you know? Yes, so it is the area which is nothing but it was trapped under the fresh water conditions, and therefore we have the coal. Where you have the marine petroleum resources? कहाँ पे है? Mumbai high, Baseen high. Yes, so please remember, under marine conditions they will convert into the petrol. Under this fresh water condition, if they are submerged, then this sediments will convert into coal formation. Okay, so most of India's bituminous coal is here. Also, we have some amount of anthracite coal here, that is here in the Jammu, that is nothing but Kalakot coal reserves. Kalakot coal reserves. Okay, anthracite is also here. We have some sort of anthracite as well. So this is here. Kalakot in Jammu. Okay. Rest of the area also we have the lignite coal. Okay, this is bituminous, more or less bituminous. And now I am just marking this lignite coal. Here the very famous Nayeli or Naveli lignite. Where it is? Tamil Nadu. Then we have another area. For example, here in Gujarat, you have the Umrasar. That is also famous for lignite. In Rajasthan, we have Palna. This is also famous for lignite. Okay. So mostly we have bituminous in this area. Then we have Nayeli lignite, Umrasar Gujarat lignite, Palna in Rajasthan also lignite source. Then we have some amount of this anthracite coal here in the Kalakot. Also we have one site here in the Jammu which is also famous for lignite, that is Nicha Home. Burja Home, Nicha Home. So Nicha Home is the site where the lignite is also found. Okay, so these are the coal sites of India. Okay. Carboniferous is over. Permian is not much important. Permian is important only for potash reserves across the world. They were formed around this Permian time. Not required. Next we go to Hanji. This is all lignite. Bituminous is mostly concentrated here. Anthracite is in Kalakot. Okay? Some areas here in the northeast also have the coal, which is what is the name? Namchik Nampuk. In this area, that is tertiary coal. Okay? Now come to the next one, that is, see here we are done with the Paleozoic. If we come to the next one, Mesozoic. Mesozoic is divided into how many? Triassic, Jurassic and Cretaceous. Now this is not important. See here, Jurassic is important for the dinosaurs, right? Now, what is the time period which is important for me is this one. So this is known for what? Extinction of dinosaur, number one. Now, this is also the time period that you will remember, not only extinction of dinosaur. Why they got extinct? What happened exactly here? The two things you will remember about this one, extinction of dinosaur, and second thing that you will remember for the Cretaceous is cooling of Earth. Now this cooling of Earth was going on, and this third thing that you will remember, the meteors were entering more or less inside our atmosphere. So cooling of the Earth was resulting into more and more volcanic eruption, yes or no? So volcanic eruptions were there, number one. And the second is meteoritic hits were common at that time. Meteorites and meteors, okay? Meteorites. Now see here. The dinosaurs were the big creatures. And now what was happening? See here, for example, this is the Earth. The volcanic eruptions were going on. With this eruption, what happened is it is believed that dinosaurs could not run faster to escape this volcanic eruptions. And they were surrounded by this volcanic matter all the around. Okay, number one. Those who anyhow ran to save their life, then meteoritic hits were common by then time. Okay, and therefore what is believed? It is believed some of them were also killed by this meteoritic activity. So why they got wiped out? Because of two reasons. Number one, because of the volcanic eruptions where they could not escape this volcanic matter. And the second, those who were anyhow running and they were trying to climb on the trees also, they were hit because of this meteoritic hits. Okay, so this is the one thing. That second thing you will remember, see here, with this volcanic eruption across the world, we have the volcanic plains and plateaus which originated in this time. What is this time? That is, I'm talking about which time period? This is, I'm talking about Cretaceous time period. Now this Cretaceous time period, you will remember for three things. One, extinction of dinosaur because of these two activities. Next, you will remember, due to this volcanic eruption, the plains, that is volcanic plains and plateaus were formed. The example of such plateaus, number one, what is this plateau? Deccan Lava Plateau of India. Deccan Lava Plateau was formed by this time. Second, that is Siberian Plateau was also formed by this time. Third, Snake Columbia Plateau. Where it is? North America or US, okay? Snake Columbia Plateau, they are the example of volcanic plateaus and they were formed in this Cretaceous time period. Okay? Done? The last time period, that is Cenozoic. In the Cenozoic now, Cenozoic, the one is, here it is Quaternary. Here it is not written there. Acha. Slightly this part I already mentioned, that is going to be slightly theoretical part and therefore it seems a little difficult, but it actually not. It's not. आप भी किसी foundation में थे ना, the guy, है ना? Which year? अच्छा अच्छा, अभी करंट हैं आप. Okay. Till here, everyone? Fine? From here, after, the more interesting part will start. That is the theories and the continental drift theory, seafloor spread theory, convectional current theory, plate tectonic theory, interior of Earth, from here onwards. This is thoda sa theoretical part. Now we come to here. See here. See here, we have discussed up to here. This is, see here, age of dinosaur, extinction of dinosaur. Here we have further understood the volcanic eruptions were there, plains and plateaus were forming. Now we are coming to tertiary. Tertiary is divided into, see here, from the bottom. That is PEOMP. If you see the sequence, how to remember this, that is PEOMP, PEOMP. See here, PEOMP. This is PEOMP. Now P stand for paleo. Paleo means the older, and this stand for paleo. And rest of them, say Eocene. That is Oligocene. Then Miocene, MIOCENE, then Paleocene. This is Paleocene. So everywhere you will attach this word seen, and this is PEOMP. This is how you will remember the sequence. In this, you will remember these are very trivial information, not required. The only thing that you will remember here, this is known for what? This is known for the tertiary mountain origin. That is nothing but alpine. The Alps and Himalayas, they were originated in this time period. So Himalayas got originated in this time period. You will remember that. Okay, for the formation of Himalaya. Now see here, can you relate this formation of Himalaya with the increasing plate tectonic during this Cretaceous? In the Cretaceous, what was happening? The volcanic eruptions were common. It means the plate tectonic activity was very common. So this trigger mechanism for the formation of mountain started right in the Cretaceous itself. And from here onwards, you will see the mountains across the world. They are going to be Alps, Himalayas, and they were originated in this tertiary time period. Okay. If you see the more precisely, Great Himalayas form in this Eocene and Oligocene together. Then mid Himalayas here, the Great Himalayas here, and from the mid of Miocene till this Pliocene, your Shivaliks were forming. Okay, so sequence, see here, Great Himalaya, mid Himalaya, Shivaliks, Eocene and Oligocene together. This Great Himalaya finished in Oligocene, mid in Miocene. From the mid of Miocene to Pliocene, Shivaliks were originating. Okay. And the last one, here we have learned one more thing, Deccan Peninsula, that is Deccan Plateau was originated here. Aravalli we have learned here in the bottom. This is Aravalli. Okay, now come to the last one, see here, Pleistocene and Holocene. Pleistocene is known as for the ice ages. How many ice ages were there? 4 were the ice ages. Ice ages were total how many? 4. If you want to write the 4 ice ages for the prelims, you should know Gunj, Riss, Minde, and Wurm, WURM. This was the last ice age. Wurm. Okay. Gunj, Riss, Minde, MINDE, Mint, and Wurm, WURM. How you can remember this sequence? You can remember in this way. If you understand Hindi, this is Garam. Okay. And this is Wurm. The last ice age was Wurm. Okay. Now see here, the last ice age finished here in the Pleistocene. This was the time period where the last ice age was finished. Known for last ice age. And after then, whatever the time period is, it is known as Holocene. Holocene started after the end of the ice age. Okay. Holocene. That is nothing but Holocene is known for present day human civilizations. Okay. Holocene will be divided into again 3. Okay. Holocene is it given in your handout? Holocene is divided into 3. Now, if you see your handout, and I am just saying here, one is the Greenlandian, then North Grippian, and then finally we have Meghalayan. Which is the recent one? Meghalayan, only 4,200 years before. Meghalayan age is the classical example where this is the only geological age which coincided with the collapse of many civilizations of the human being. The examples I have given you, Egypt civilization, the Indus civilization, and across the world, whatever the civilizations were there, they were collapsing down. Why they were collapsing down? Because of the mega drought event and the cooling of the earth was responsible for lack of rainfall. Because of less rainfall, what happened is these humanity, that civilizations earlier, they were based on what? On the resources. Which resources especially? They were located near the water bodies, and therefore what happened is because of this drought they could not survive. And this is the only time period, that time age of the entire geological time period, which coincided with the collapse of many civilizations. Now how we come to know that this mega drought event occurred? We need to have some signature. What are these signatures? Some signatures of the atmospheric conditions prevailing at that time. So what can be used as an atmospheric signatures? You can use the ice core samples. The ice which is inside deeper, their cores can give you the example what kind of atmospheric conditions were prevailing by then. Second, inside the lakes and seas, if you will go, the sediments can be found. These sediments, pollens, they can also be give you the idea about the atmospheric condition. And the last thing is the isotopes of oxygen, they can have also this property. They can chemically store the signatures. That what was happening by then. If you see the Meghalayan age, please see here. This is the last part of this time period. Now see here. This is the caves, if you are aware about them. In the Meghalaya, there is a very famous cave, Mamlu Cave. It is given in your handout, Mamlu Cave. This is one of the deepest cave in the India. Now, these caves are known for this kind of structure. Some from the roof, this is known as stalactite. Some from the ground, they are known as stalagmite. And some, they will be a kind of pillars. This kind of pillars would be there. Now, because they are deepest cave in the Meghalaya, we have recovered the oxygen atoms from these pillars, that is from here and here. These oxygen atoms, because they were deeply located inside, they still have the information by then what happened. Okay? So this signature, that is chemical isotopes of oxygen, gives idea about climatic conditions of the past. Okay. So why its name is Meghalayan age? Because we have recovered the samples of the oxygen and its isotope from which caves? From the Mamlu caves located in the Meghalaya. So please remember this much of the information, at least for GS, this one, geological time stamping. Again, I'm repeating. See here, you will just now look at the board, simple. Because it has the chemical properties. If you will see its isotopes with the scientific analysis, you can find out what conditions were there. Temperature, pressure, that type of conditions. Okay? Now see here. In the geological time scale, see here, quickly, let me give you the glimpses. We started from the bottom. In the bottom, we have Hadean, then Archean, then we had Proterozoic. These combinedly three are known as Super-Eon, or they are combinedly known as also Precambrian time. In this time period, we have seen the oxygen came into being, life form came into being, then the oldest rock, Aravallis, were also there. Okay? So this was the feature. Then we came to the next time period, that is starting from Cambrian. The Cambrian was known for marine invertebrates. Then we have coast cap, if you will remember, Ordovician. Kya hua? You are here? You are not there. Bring your soul back. Okay? Physically you are here. So see here, Hadean, then Archean, Proterozoic. We started then from here, that is in the Paleozoic, we have Cambrian, then coast cap, O, Ordovician, then S, Silurian, then Devonian, then Carboniferous, then Permian. Now if we see the sequence, now tell me where the first fish came out. The time period famous for amphibians. Silurian is for leafless plant, after then Devonian. Then Carboniferous for the coal formation across the world. Permian, not so important. Jurassic for the dinosaurs. Cretaceous for extinction of dinosaur and formation of plains and plateaus. Then come to the next, tertiary. Tertiary divided into Paleocene, Eocene, okay? Then Oligocene, then Miocene and Pliocene, known for the formation of Himalayas. Then come to the next one, that is Pleistocene and Holocene. Pleistocene and Holocene, or we can say Quaternary, is the time period when your Great Plains of India are going to form. Okay? After the formation of Himalaya, the rivers were bringing the sediments, and this was the time period. Quaternary is the time when your landforms like Great Plains were formed. Okay? So if I arrange these plains, see here, if I arrange these features from newest to oldest, can you help me? New features and the oldest features. New to old I am arranging. Now tell me, Great Himalaya, number one. Number two, let's say Shivaliks. Then Great Plains of India, Great Plains, then Peninsula of India, Aravallis, Peninsula peninsular India or the peninsula of India. Aravallis, Great Plains I have written here, okay, and then Deccan Plateau. First tell me which is the youngest out of them. Great Plain is the youngest, okay, fine. Then Shivalik is the second youngest. Then Great Himalayas, okay, they are the third, fine. Then Peninsula or Aravallis or Deccan Plateau? Deccan Plateau. Deccan Plateau. Deccan Plateau. Peninsula. Peninsula. Or Deccan Plateau. Deccan Plateau. Okay, Deccan Plateau is the correct answer. That is Cretaceous. Then talk about this two. Peninsular India or the Aravallis? Which is the oldest? And what about peninsular, this plateau? That is peninsular India. The peninsula of India. Aravallis would be next, and then? Yes, they too are in the Precambrian, they too were there. Now tell me where the Aravallis will originate. Kahan pe banenge? On the peninsula, na? It means Aravallis were formed on the Precambrian, then Deccan, this one, peninsula must be existing before, yes or no? Yes. So they too are Precambrian features. So this is how you can use this knowledge of the geological time scale in arranging the landforms. Okay. So this is over. Now we are coming to the theories. Up to here, everyone is fine? The theories part we are going to start now. The first one is continental drift theory. Continental drift theory. Remember this thing for the UPSC, when they ask some question in the prelims, that same area becomes crucial for your mains also. The mains questions and related area becomes important for your prelims again. If you go back and see 2025 prelims question, the Wegener's theory and evidence they have asked. Okay? The same more or less question was framed around this mains, in the mains. They asked how continents and oceans rearranged in terms of their shape and size. Discuss. So here you were supposed to mention in the mains, you were supposed to mention continental drift as well as plate tectonic theory. And with the examples, you were supposed to write some good answer. Okay? So this is how in the prelims this question was asked. More or less around the same area, the question in the mains was framed. Okay? So be careful if the question themes are there in the mains, try to create the prelims related areas around them and just go through them. Continental drift theory given by Mr. Alfred Wegener. Alfred Wegener was the man. The first and interesting thing is he gave his theory in 1912. It came into light only in 1922. He was not a geographer. He was rather a meteorologist. Okay, meteorologist means who studies the climate and climatic patterns. Now he was visiting all the areas around and he found some of the climatic anomalies. What do you mean by this climatic anomalies? Yes, the natural climatic conditions are not there in the area where he was visiting. For example, here, see here. This is the earth. If I say this is the equator. Now India is somewhat here. This is India, right? That is around 23. I'm just locating here. And then if we see this Sweden, it is somewhat here, right? Now tell me where in general condition coal formation should occur. In lower latitudes or in higher latitudes? Coal formation is the feature of lower latitude. It means if the coal is found in India, is it fine? Yes, it is fine. But if the coal, same coal is found in Sweden, then Sweden is located in higher latitude. It is not something which is normal. Therefore, this was climatic anomaly for whom? It was climatic anomaly for Wegener. Higher latitudes are known for what? Low temperature. The low growth of the biodiversity. Biodiversity, if there is less, what will happen? How the coal formation will happen? We need some vegetation to be trapped, na? In the higher latitudes, you do not have much of the biodiversity. So how come this coal formation is possible there? Yes. The second thing, when he visited India, in this India's area, for example, here it is, this is the Gond area. He found there are the evidences of past glacial activity. And this glacial activities evidences he recovered, that is the glacial till. What do you understand by glacial till? glaciers are very heavy and dense. Whenever they pass through some area, they will grind the surface very into a fine powder. This kind of fine powder will be known as glacial till. He recovered this glacial till in this area of the Gond tribe. Therefore, he will give some name Gondwana to his land parts, right? Now, this was something which was intriguing for the Wegener, that how come in this just near the equator, past glacial activity was possible. This was also an intriguing question for him. Yes. Now, when he started giving his explanation with this climatic anomalies, he considered two possibilities. What are the two possibilities? See here. The first, he is considering that maybe India was not here, Sweden was not here in the past. Somewhere Sweden, this was located here and India was here. Then what happened is India and Sweden started moving this way. Maybe this was the logic, and therefore near the South Pole when India was, it had the glacial evidences. Because Sweden was here near the lower latitude, therefore it has the coal-based features. So one possibility that he was considering, that maybe the location of Sweden and India as a continent that was different in the past. And then they moved in this area. So what he is assuming? He is assuming the climatic pattern, that is South Pole was here, North Pole was here, and the land was moving from here to there, poles were stationary, or the climatic conditions were stationary. So number one, he considered that climatic conditions were stationary and the land masses were moving from one area to other. Second possibility, when he is assuming that India and Sweden were located here only. See here. This is India, this is Sweden. They two were located here only. But what happened is, maybe in this kind of assumption, he assumed South Pole was here, the North Pole was here, and maybe equator was passing through this area. Therefore, Sweden had coal. The India was near the South Pole. Therefore, India had the glaciers. Yes or no? Yes. Two possibility he is considering. One, he is considering maybe these two locations were here only, but the climatic patterns were different. And the second possibility is maybe climatic patterns were not changing. The location of these continents were something which was changing. So with these two possibilities, he went with possibility number one. What is this possibility? He considered that the climatic conditions were stationary, or the patterns were stationary, and the land was moving across the history. And therefore, his theory is known as continental drifting theory, because he considered continents were drifting in the past and now they came up with this modern setup. Okay, so with these two possibilities, now see here how his theory is given. See here, the two possibilities, out of that he is assuming continental drifting. Okay, now see here, for this drifting to occur, some forces are required. And what forces he gave? The forces that he is assuming. See here. So first, before giving his theory, he made some assumption. The first assumption that he made, he said that in Earth, I believe in this three structure of the layers. One is Sial, second is Sima, and third is the core, or that is nothing but knife, right? And in that he considered that Sial is floating over what? Sima. Okay, so he considered number one assumption, three-layered structure. He assumed where Sial floats over Sima. And when he said Sial floats over Sima, he said without friction it is happening. Without friction. That is number one. Without friction. The second assumption he is making about his forces. Now, what are the forces he is assuming responsible for this drift? The number one force is, second assumption is about forces. So the first force that he held responsible for this drifting, it was tidal pull of sun and moon. Number one. And second was, yes, the force of buoyancy. Then third was gravitational pull. Gravitational difference actually he used as a force. Buoyancy, because he was assuming that the continents were floating, and this is his assumptions. And one more he assumed, that is centrifugal force. You will come to know how centrifugal force he used. Okay, centrifugal force. Now see here, he actually considered that this will be responsible for westward movement of the land masses. And he considered that this gravitational pull, this will be responsible for equatorward movement. And the third that he is assuming, centrifugal force, you will come to know, okay, how this will contribute to the pole flea theory. Now his theory, in that theory, he is assuming, see here, this is the earth. He is assuming, here it is the pole, here it is the pole. He is assuming, actually in his assumption, when he is making that Sial is floating over Sima, essentially he is considering Sima as ocean. And he is considering that on this ocean, the land is floating. Okay? And therefore he used this word, buoyancy. Okay? According to this buoyancy, whatever is floating, it will be helped by the water, yes or no? Yes. Now, when he was assuming this, he was considering that because of Earth's rotation, the Earth was rotating. Because of Earth's rotation, what will happen? Centrifugal force will come into the picture. What is centrifugal force? When I rotate something, the force will be there outside from the center. Now, this force was radiating outside. So, this is the force. Now, he is considering because of this outside force, what is happening? This earth is bulging here. This earth was bulging here. That is true also. Yes or no? Earth is bulging, and because of this bulge, he is considering, because according to him, the land was just moving over the water. He is considering this land, that is the continent, started drifting because of this side, because of this centrifugal force and the bulge here. So he is considering because it is bulging, the slope was in favor, and therefore what happened is the land came down towards the equator. However, it seems very irrational and unscientific, but this is his theory. I am just messenger. Okay, so don't see कि sir ऐसे क्यों पढ़ा रहे हैं. I'm just messenger. I'm delivering his message. So according to him, the centrifugal force created this sphere-like bulge. Because of that, the Earth started. See here, Earth was like this, according to him, and therefore he considered if I put some bowl or something here, it will roll down. So he was assuming also in the same way. He thought कि because of the centrifugal force, the land will move from pole both the side. Okay, both the side from pole to the equator side. Okay, so this is his assumption. Now come to how he proposed his theory. See here, in order to cover this faster, pole flea theory. Why? Because he considered that the land parts were moving away from the pole or towards pole. Away from the pole towards the equator, and this is how the land masses were moving away from the pole. So therefore his theory is known as pole flea theory. Means the land masses were moving away from the pole. So pole flea theory. And what was the force responsible for it according to him? Centrifugal force. Okay. Now come to his theoretical part. What he gave and proposed as a theory. See here now. So in his theory, he assumed that everything started, this drifting and all, just from the Carboniferous time period. Okay. Carboniferous, just now I talked about. Where this Carboniferous was? कहाँ पे था? मेसोजोइक और इन पेलियोजोइक. अभी अभी किया, ऐसे मत करो. It is in Paleozoic, before Permian. Okay, Carboniferous. See here, in this theory, he mentioned that in the Carboniferous and just before Carboniferous, everything was existing in the form of supercontinent that was known as Pangaea. And this Pangaea was surrounded by what? It was surrounded by the water, and this was, he was calling as Panthalassa. Now what happened is, because of the forces responsible that he assumed, and more primarily he was considering the difference in gravitational force of various areas, the rifts were forming. What do you understand by gravitational difference? Some of the areas with more mass will have more gravitation in the earth. Some of the area with less mass, they will have less gravitation. So what was happening? The more one are attracting the land towards them compared to lesser one. And he is assuming that because of that, rift was created. So why the rifts were created? The openings were created, according to him, because of the gravitational difference was existing inside. Therefore, the rifts were opening. The rift, what do you understand by rift? What is the rift? A narrow opening, can I say? Yes or no? Yes. Now he is assuming after Carboniferous, what happened is this Pangaea broke into two. One is northern part, second is southern part. In between, there was a gap which was filled by the water. And what is this gap now known as? This is he was calling as Tethys Sea. The rest of the area is still Panthalassa. Northern part was given the name as what is the name? Angara or the Laurasia. And this one was given the name as Gondwana land. This further broke into three, that is the North America, Greenland, and Eurasia, Europe and Asia, Eurasia. Whereas the Gondwana land will break into, tell me, Africa, South America, Asia, Africa, then peninsular India. The Asian part is here also, Eurasia. The peninsular India, that is peninsular India, then Australia, Antarctic, and Madagascar. Okay. Antarctica, yes. So this is how the land masses were coming out from the same Gondwana land. Now see here, let me give you this pictorial representation. Done up to here? Yes. See here now. That is, he is assuming Pangaea here. After the Pangaea, he is assuming Laurasia, and here it is Gondwana. And now see here, from here, what will happen? See here, from here, what will happen? Laurasia will break into North America, this side, then Greenland here, and then Eurasia. And this one, that is South America, will start moving in this direction. North America and this South America, they two were moving in which direction? Southward or the westward. Why? According to his assumption, what was the force responsible? Tidal pull of sun and moon was pulling them in the west. When they were pulled here, see here, if you see this areas, please be careful. If you see from here, the rift will form here. Yes or no? The opening will form here, and the water that is of Panthalassa can enter into this. Yes or no? Yes. And what will happen? You will see this kind of rift will open, and here you will see S-shape Atlantic Ocean formation. Why S-shape? See here, because according to him, North America was moving faster than South America. There was the difference in speed, and therefore this difference, see here, this is the S-like difference, where the North America was pulling more, means it was moving faster, and South America was still here. Okay? So S-shape opening was open, and this is nothing but your Atlantic Ocean. Done. So Atlantic Ocean was opened up. Tethys we have already learned. And now see here, from here, India will start moving in this direction. When it will move, the Tethys in between, this one will be closed. And in the bottom part from where India started its journey, here you will see the formation of Indian Ocean. Okay. So we have learned this is Panthalassa, Tethys Sea. Tethys Sea will be closed. Indian Ocean will be opened, and S-shape of Atlantic Ocean is going to open up. From here, he has assumed, see here, from here he has assumed that because land was moving away from the pole, therefore what will happen? Here the ocean will form. Again, rifting will happen, and here the North Sea, the Baltic Sea, they all will be formed due to this phenomena. S-shape is when the North America is moving faster. The South America is still here. It is nothing. Simple. He gave this reason. That is, the North America was moving faster compared to the South America, and it is now believed and established also. The North America as well as Greenland, they are moving faster. Okay? He spent his entire life on the Greenland, almost entire life, when he was doing this research and all. And do you know, he also died on the same Greenland in a snowstorm. It is also the Greenland which is moving fastest out of all the plates. And it is also known for this kind of mystery, because Wegener was spending his all the time. This is the Greenland which was moving faster. Okay, it is coincident, but this is moving faster. Therefore, Greenland is also termed as tectonic bullet train, because it is moving much faster than rest of the plates. Okay, now come here. He is seeing, see here, he is saying That Gondwana is resulting into the formation of South America, Africa, Antarctic, Indian Peninsula. This is Australia, and here it is nothing but your Madagascar. And this is how the various water bodies are opened up. See here. This is the remnant form of Panthalassa. That is nothing but your Pacific. This is also your Pacific, remnant Panthalassa. This S shape of ocean is why? Because of North America was moving faster than South America. These all oceans are opened up here according to Wegener. Okay? Why? Because the land parts which were available here, they drifted away from this area and they left this area vacant. This is nothing but the water bodies were opened here. Baltic Sea, North Sea, Arctic Sea, they were formed because of this. Tethys Sea now is existing in the form of remnant in form Mediterranean. In between this India, when India started its journey, Tethys closed here and Himalayas started forming. Here, when India moved from here, this resulted into the formation of Indian Ocean. That is his theory. And now see here, when he gave his theory, see here, everything is written in your handout. Just see there, how the various land masses are forming, everything is written. See this? Okay? Now, when he found this evidences, the evidences, if one evidence I tell you, see here, he considered, see here, when he was giving his theory, he was right also, because in terms of evidences, we have found here, this is the pole, okay? And here the glaciation was there in the especially Carboniferous time period I'm talking about. In Carboniferous, because of the glaciers here, you will find the glacial evidences in South America. You will find the evidences in this Africa, India, Madagascar, this one, as well as in this area because it was close to the South Pole. So this is the one of the evidence which was found by the evidence in all of the parts of this Gondwana. Okay? He also found this evidence in India as well. Yes or no? Yes. So that is the glacial evidence that he found. One by one, now we will understand his theory we have learned. Now the evidences. What are the evidences based on which he was giving his theory? See here now. Yeah. It is the name, other name of the continental drift theory. Yes, yes. He said this theory as pole free because all the land parts he assumed were moving away from the poles. Buoyancy means if something is floating, what will happen? This flotation will be supported by the water. Okay? That is known as force of buoyancy. And he was considering land is floating over the water. And therefore, he was considering the water is also supporting this movement. Okay? Now see here. See here, one by one, the evidences. See here, number one, the very famous evidences. If you see this too, that is here. The South America can be exactly fitted with the Africa. This one evidence is known as jigsaw fit. Okay, it means it seems like the two were together always. Okay, before this drifting away of the moment. This is one evidence. Second evidence, what you will find, see here. Second evidence, if you will see the rocks of this area, see here, the rocks of this area and the rocks of this area, that is nothing but the equatorial western part of Africa and the eastern part of Brazil and the South America, they show remarkable similarity. Similarity in terms of structure. Also in terms of formation, means they have the kind of minerals which are more or less same. So second evidence is the rocks of the two sides, that is here, they show the similarity in terms of their structure and the formation. Third evidence, the very classical. Done with this? Second, is it written in your handout? Just mark them one by one. The third evidence is, see here, here we have one coast, that is Ghana coast. Okay? And here we have the placer deposits of the gold. This is gold deposits here. Now this is placer deposits of gold. Anybody? What is the placer deposits of the gold? Yes. For example, there is a river. See here. For example, sorry, this is the rock. See here. Inside this rock, some particle of golds are there. And if there is some river which is coming with the water, over a period of time that will be weathering down and this eroding down this rock, yes or no? Yes. And in that process, some of these particles, which are gold particles, may come and deposit in some areas in the low-lying areas. Okay. So these particles, they are known as the placer deposits of the gold. So these are nothing but the gold ions which are brought by the gold particles which are brought by the rivers. Okay. The river which was famous in India also there. What is the name? Subarna Rekha. It was also famous for placer deposits earlier. Ab to nahi milte, but earlier. Now see here. In this case, see here, there is no such river and the such rocks, that is gold bearing rocks. Then how come this gold deposits are here? How they are here? What could be the reason? What is the reason? What is the reason? Yes, what is this river here? The very famous river. What is this river? Amazon River. Amazon River is bringing or was bringing here. This was the rocks here, and from this rock, gold particles were brought here. And this deposits, placer deposits in the Brazil, they are also in structural similarity with this placer deposits of the this side. That is equatorial Africa's western side. And this was asked in 2025 in the prelims. Okay? That was the question. That is, these placer deposits is also one of the evidence. The three evidences we have seen. Fourth evidence now, see here. This is mesosaurs. Okay? These are the organisms which are found in Africa and South America. But you can say, sir, this can, let's say, swim. Yes, na? You can reject this claim of as an evidence that, sir, this can swim. Maybe this has traveled from the South America to Africa. This is the possibility. Therefore, we will use the evidences of flora fossils. So this flora fossil is something which is important. That is Glossopteris. Glossopteris flora. And it is found everywhere of the parts of the Gondwana. It means where it can be found. Glossopteris flora can be found where? Can I say South America, Africa, Antarctic, India, then Australia and Madagascar. Everywhere it is found, which are the part of Gondwana. So that will be considered as an evidence. 4 evidences from the last, means this equator's southward side. Now we are going to the northward side. Now if you see the northward side, see here. And one more, last. From the southward side only, the past glaciation. Which time period? Carboniferous glaciation of the past. Glaciation of the past. Where you will find the evidences? In on all Gondwana part. Tell me where you will find now the evidences. India? Yes. Australia? South America? Africa? Madagascar and Antarctic. Yes. So this is the 5th evidence. Some more evidences. See here now. See here. Now we are going to the north side. Now if you see this one, see here. If you see, this is America's Appalachian region, known for coal reserves. The one which I was mentioning here, the coals of Kiruna, do you remember Sweden and all? Yes. So coal is also found in this area. Now if you see this coal formation here, they too have again a structural similarity. It seems like they two are similarly in terms of structure and feature. How come this is possible? Can I say once because they were united together? Yes or no? Yes. So this is the coal and its structure similarity. The second similarity will you see here, that is the rocks from here. Which part of the America, tell me? Northeastern part. The rocks from here, that is your Greenland. The rocks from here, that is nothing but your northwestern upper parts of the Europe. They all have the similarity in terms of their structure and formation. So the similarity of what? The similarity of rocks. The similarity of coal. They two are the things here. Okay. The another evidence that we have now established, that is North America as suggested by Wegener is moving in the which direction? Yes, and the Greenland is also moving in the westward direction. So this is also one of the evidence. Now another evidence is, see here, done with this, see here the rock similarity here. This is the rocks which are similar because earlier they were connected together. Yes. Now come to the next. How many evidences we have seen? 5 तो नीचे ही देख लिए थे. 7. 2 more we have seen na in the northern side. 2 we have seen, not 2. We have seen 3, 4. 1 again I'm repeating. 5 we have seen in the southern side. One, we have seen the similarity of coal. Second, we have seen the similarity of rocks. Third, we have seen both they are moving in the westward direction. So 8 evidences we have seen so far. The last one, see here, Scandinavia. This is the countries here. Scandinavian countries here, they are known for this kind of coastal area. This is the coast that you will find there. What type of coast it is known as? It is known as fjord. What is fjord? You will not see any beach or something here. Directly you will see mountain like cliff here. Okay? This is ocean, and from the ocean directly you will have cliff. This is the land. Okay? This is known as fjord or the fjord. Okay? This is known as fjord coast. Now see here. In this area, when this was united together in the past, there was one animal which was found lemming, and still now it is found as lemming. Now these are the lemmings which are rat-like organism, rat जैसे, ठीक है? Now when they increased in terms of their population, see here, earlier this was stitched together. Whenever their population was increasing here, they used to run in the western side towards America and towards in this area, always in the western side. Still they have their ancient memory, which is making them to believe that whenever the population is increasing, where will have to run? In the west. So what happens is now they are not aware Wegener has proposed this theory, and there is nothing in front of this area. The land is not there further. Still they run in the west without knowing fjord coast, and they jump inside the ocean. This phenomena, when they jump in mass and bulk, is known as mass suicide phenomena of lemming. That is also one of the evidence. That is behavior of lemmings. Okay, that is it. So these are the all evidences in favor of whom? In favor of Wegener's theory. Now we will sit together and criticize his theory. Tell me, what are the criticisms? What do you think? So what assumptions according to you are wrong? Criticism one by one. Yes, okay. All of the land masses were not moving westward. Okay. So can I say his explanations were incorrect? And two more things. The explanations, not only he gave the explanations of the continental setup, but also some of his students were sitting as you are sitting. They asked, sir, in this time period of 1912, when religious explanations are being given, what is the structure of the earth? And this was also the dark period, right? In that time period, you are the one who is explaining us scientifically that how this land masses were moving. Please also give us insight about formation of mountain. Wegener was very happy because he had this knowledge. He said, okay. So what he said, see here, everybody, he said, do you remember I said Sial is moving over Sima? Everybody said, yes, sir. Then he said, see, this is Sial and it is moving over Sima. Okay? When it is moving, the frontal edges here, they are scratching this Sima. And when this scratches are going on here, the material is created here because of resistance and friction. The sediments are being created. And with this side movement, where the sediments will pile up? They will pile up upside in this way. So what he is saying, see here, when we explain his formation, see here, see here, see here. So he asked this question, that is, I already said in my theory that this is the Sial and it is moving over what? Sima. And when it was moving here, the frontal edges, they were breaking. Why? Because of what? Because of the resistance and friction. And this sediment supply and this entire surface was folding up in this way. And therefore, what you will see, the mountains you will see, in which side you will see the mountains? In the west side of the continent or in the east side of the continent? He is assuming this is continent. So in the west side, you will see the mountain. He gave the example. For example, he said, if you believe this is the America, where is the Rockies? Everybody said, yes, sir, it is in the western side. Where is Andes? Western side. Everybody was so happy. But somebody questioned him, sir, but you mentioned in your assumption that Sial is moving over the Sima with friction or without friction? And now you are saying with friction, these mountains are forming. He said, please erase that point, without friction, and now add with friction. Okay? So that he can explain the formation of mountain. However, he could not explain the formation of some more mountains which are in the middle of the continent. For example, Alps. Yes, he could not explain that. So this formation of Himalayas and all, that was also erroneous, or the formation of this kind of mountain was also unscientific. Is it correct? Answer is no. That was also criticism. Somebody asked, okay sir, theek hai, mountain B, we got it. Now tell us how this Caribbean islands, Jamaica and all, this is created. How the Japan is created. He said this is more simpler than mountain. Everybody asked, sir, how? He said this is the whole land which was moving faster, let's say at the rate of 10 kilometer per 10 million years. This was the areas, they are the leftover parts of the mainland. They were not moving as faster as this entire area. So this leftover territories are nothing but our island. Everybody was so happy कि island formation भी सीख गए हम लोग, ठीक है? So now the people, those who are the staunch believer of the this theory, they were highly happy. They now have the knowledge of not only the present day setup of the continents, they know how this formation of mountain has happened, and they were also knowing that how these islands were created. However, they were wrong. Now come to the criticism. What were the criticisms we were talking about? Tell me now, one by one. His assumption, Sial floating over Sima without friction, was wrong. Then his explanations were his explanations of mountain, continental setup as well as island, they were not correct. Third, were his forces correct? Answer is no. Why? Tidal pull of sun and moon, if you assume that they were pulling the continents, then at that time they must have been 10,000 million times stronger, because all this setup was combined together, na? So what today the force, combined force of sun and moon is, to break this entire setup when it was together, 10,000 million times these forces must have been stronger, and they may have resulted into complete stoppage of the Earth's rotation. And it means the day and night formation must have been stopped there. We haven't seen this kind of phenomena where day and night formation stopped on the Earth's history. Therefore, he was wrong. Yes or no? So his forces were unscientific. His explanations were unscientific. He could not explain why exactly in the Carboniferous these things happened. What exactly happened in Carboniferous? Why this Pangea got disrupted? He could not explain. And so many things were in his explanations incorrect. Okay? So mainly these were the criticisms. Now when it comes to his contribution, what you will say, his theory, why his theory was important, why we are learning? Because it is the part of our syllabus, sir. Why we are learning? If all the things are incorrect, why we are learning then? What is the correct thing about his theory? What he gave us? Shape of the earth. Nahi. Shape of the earth was established way back. A sphere shape it is. है ना? One homework I am giving you. ठीक है? What is the homework? You will tell me what are the evidences which suggest earth is spherical. ठीक है? This is important for your prelims. Earth is spherical. What are the evidences? Magellan. That is that is the voyage, first voyage, that was Magellan's experiment. है ना? Then we were talking about Wegener. I will go to this spherical shape. Just tell me. Yes, his contribution, Wegener's contribution. Why Wegener should be remembered? Why his contribution is more important for us? Why? Pangea. क्या Pangea? उससे क्या करेंगे हम? ठीक है, that was evidence. Okay. Anybody? Okay. Any?
Provided the starting point for other researchers to think about it.
Okay. Yes. What is the contribution? Can I say in that way that he was the one who provided us the first time idea that continental drifting occurred in the past? Yes or no? And this was not in this setup always. Earlier, the setup of the continent was different, and now the setup of the continent is entirely different. So what is his central idea? His central idea was continental drifting had occurred, and this was widely accepted and widely appreciated by the geographers community. However, he was criticized for a lot of things, but his central idea of the horizontal drifting of the continent was widely recognized. The only problem with the Wegener, do you know what? He was not looking from the point of view of scientific observer and neutral observer. He rather established his all theory on the premises as if he was an advocate. What advocates do? They manipulate the evidences to prove their point, and he also manipulated his resistance and without resistance part in order to explain the formation of mountain without going for thorough this explanations and scientific, let's say, deep insight. He just modified this fact, and this is his contribution, and as well as criticism evidences we have seen. This is important for PLIMS. Okay, the next theories that is we are going to discuss. I think it is the time for break, right? Okay, we have crossed, I think, time. Huh? So break of 15 minutes. We'll assemble back after 15 minutes.